Yes. So the first reaction is called as a reaction very similar to the Fehling solution, which is called as Benedict's solution. Here, in Fehling's, we had alkaline copper sulfate plus sodium potassium tartarate. The only difference we have in Benedict's is that you have same alkaline copper sulfate. You can see sodium carbonate is there, which is a basic salt. Alkaline copper sulfate. Instead of tartarate, here you use citrate. That's the only difference we have. We saw the Fehling's reaction as follows, where you have aldehyde, copper 2 plus reacts, where aldehyde you can see it is getting oxidized and copper 2 plus getting reduced. The red precipitate that you form is nothing but Cu2. Same reaction applies for Benedict's as well. The same reaction applies for Benedict's as well. As we mentioned that Fehling's is not applicable for aromatic aldehyde. Similarly, Benedict is not also applicable for aromatic aldehyde. That was a reaction with Benedict solution, and you can understand that definitely it is not a qualitative test for ketones. The next reagent is Schiff's base. Next reagent is Schiff's base. So what we have is an aldehyde. You can use both aliphatic as well as aromatic aldehyde for this. Both are possible. You can use it. Treat it with a Schiff's base. It generates pink color. It generates pink color. So when you are having aliphatic aldehyde or aromatic aldehyde, treat it with Schiff's base. It will form pink color or magenta color. Okay, so this is your Schiff's base. What you're seeing is a Schiff's base here. You're treating it with an aldehyde, where it is going to form magenta color. It forms magenta color. The next reaction is mercuric chloride. I have aldehyde. Aliphatic aldehyde reacts in this reaction, not aromatic aldehyde. Treated with HgCl2, mercuric chloride, where you can see the aldehyde is getting oxidized to carboxylate and HgCl2 is getting reduced to Hg2Cl2, white color. Once again, this would, again, the prominent reaction, one more time if it continues, again Hg2Cl2 furthermore getting decomposed to form Hg, mercury salt, which is gray in color. Not just aliphatic aldehyde, as well as formic acid also does the same reaction. Where you can see it is forming formate. Shall I continue? Written?
One minute, sir. Yes, I'm done.
Next reaction is Tishanko reaction, where we convert an aldehyde into ester. Very probable reaction. Tishanko even provided in NCERT as well. The reaction that you saw here, like Schiff's base or mercury chloride, is not provided in NCERT. So as I told you, 100% of whatever is provided in NCERT definitely replicates in your JEE question paper. So Tishanko appears in NCERT. You have aldehyde, whether it is having alpha hydrogen or without alpha hydrogen. That means it could be CH3CHO or even it could be HCHO. Here there is no alpha carbon at all. That means there is no alpha hydrogen. Here there is alpha carbon. That means it is having alpha hydrogen here. In both the cases, you treat it with aluminium alkoxide. Have we seen this reagent already, aluminium alkoxide? We have seen this reagent in MPD reduction, isn't it?
Yes, ma'am.
Yeah. So we have aluminium alkoxide in the presence of aluminium chloride. So consider I am taking 2 moles of CH3CHO. So here CHCO is there. Again it becomes OCH2R. You can see it is forming a ester unit here. Okay. Okay, pa. Consider you are having ketone. I have ketone plus HNO2, which will form oxyminoketone. That means I am creating an oxime. You can see it is an oxime, isn't it? What is an oxime? We have seen already. Whenever you treat an carbonyl group with hydroxylamine, what it forms is an oxime. Correct? So
Yes, ma'am.
I'm taking a ketone here, where I'm treating with an hydroxylamine, where it is going to form oxyminoketone. So these are the tests that we have seen already for aldehydes and ketone. The Tollens reagent, aldehydes give silver mirror, while ketones do not react it. With Fehling solution, aldehydes give Cu2O, only aliphatic aldehyde. There is no reaction here. And I introduce it with lithium aluminum hydride. Aldehydes produce primary alcohol, while ketones give you secondary alcohol. The Schiff's reagent, it gives you pink color. Here there is no action at all. When you are treating it with dry HCl gas, acetals are formed very easily. Ketones are getting formed, but not that much very easily. These are the prominent distinguishing reactions between aldehydes and ketones. We are going for aromatic aldehyde, the benzaldehyde. The following way of reactions we use to synthesize benzaldehyde. Let us start with the first one. I have toluene in the presence of CrO2Cl2 and carbon disulfide. The reaction is called as Itard reaction. Reaction is called as Itard reaction. I have toluene in the presence of CrO2Cl2. What is CrO2Cl2? It's called as chromyl chloride, which is orange vapor. The next one, I have toluene. Either I reacted with chromium trioxide anhydride form. That means it is not going to give me complete oxidation, retarded oxidation, where it ends with benzaldehyde. Or if I use MnO2 in the presence of H2SO4, manganese dioxide in the presence of H2SO4, which oxidizes toluene to form benzaldehyde. Whenever you are having allyl alcohol, okay, whenever you are having allyl alcohol, like this, the very prominent and selective reagent here is manganese dioxide to convert this alcohol into aldehyde. The next reaction is called Sommer's reaction. I have benzyl chloride and hexamethylene tetramine. Hexamethylene tetramine we are using here. where the benzyl chloride is getting converted into benzaldehyde. Benzyl chloride is getting converted into benzaldehyde. Or you could understand it would have become benzyl alcohol. Further oxidation would have given you benzaldehyde. The next reaction is Gattermann aldehyde reaction. Very prominent usage for phenolic or phenolic ether substrates. I have phenol here. Okay. If you want to convert, if you want to attach an aldehyde unit to this, for that it's very prominent. Doesn't mean only for phenols I can use it. Even for even just benzene also you can use it. Hydrocyanic acid HCN in the presence of aluminium chloride attaches aldehyde here. A very similar type Gattermann-Koch reaction. I take benzene, carbon monoxide in the presence of HCl. The reaction is called as hydroformylation reaction, where aldehydic unit is attached to the benzene. This is industrial method of preparation of benzaldehyde here. We take benzoic acid in the presence of manganese dioxide in acidic medium or titanium dioxide. NCERT has provided manganese dioxide, so we stick with manganese dioxide here. Benzoic acid, vapor form, very important, the vapor form of benzoic acid. When it is passed over
Ma'am,
and
usually MnO2 will be used for like oxidation, right?
this is an industrial method where manganese dioxide, if it is for benzoic acid in particular, it gives
Okay.
aldehyde.
No, it's not for any carboxylic acid.
No, no.
Yes, ma'am, got it.
Yes. We are discussing about the properties of the aromatic aldehyde here. It is poisonous, colorless, it's a liquid. It has a bitter almond test. This comes very prominently in the paragraph statement. There is an aldehyde, there is an organic compound which gives a bitter almond test. Okay. Certain characteristics regarding the color, the odor, the texture, certain things are a must. It's very characteristic. Then we have to definitely remember it. Of course, it is soluble in non-polar solvents. We know that.
Ma'am, what is bitter almond test?
You have this badam, na? The badam is called as almond.
Yes, ma'am.
Just imagine you're going to roast it very harsh, that becomes blackish in color, and what kind of an odor it will give. That is called as bitter almond.
Okay, ma'am.
Okay. The next one is crossed aldol condensation. What is crossed aldol condensation? What is crossed aldol condensation for? We know what is aldol condensation when I'm going to use those aldehyde which is having alpha hydrogen. Then that is called aldol condensation. What is cross aldol condensation? One of the aldehyde will have alpha hydrogen, the other aldehyde will not have alpha hydrogen. And if the condensation reaction happens between them, then I call such reaction as crossed aldol condensation, also known as Claisen-Schmidt reaction. Claisen-Schmidt condensation reaction. We know what should happen here because it is not having any alpha hydrogen. This should be the one which is forming the enolate ion, isn't it? So it would have formed a carbanion, then it would have got hydrated here, followed by heating if it is happening, then it would have given me CH double bond, CH2, CO, CH3. Correct? Children, this is one different reaction, another different reaction. Here we treated with aldehyde to get this product. Here we are treating with ketone to get this product. Clear?
Yes, ma'am.
We are moving on to the next reaction called as Perkin condensation. Reaction is very simple. All the reaction that you're seeing right now, right after the aldol, was only with respect to the carbanion generation. So we are using the acidic property of the alpha carbon of the carbonyl group. That's what we are doing here. Only thing is that we are going to change the reagents here. The next reaction is called as Perkin condensation. The word condensation definitely tells you that you're going to eliminate something so that you are creating a double bond there. The reaction is very characteristic of aromatic aldehyde. In the case of aldol, it was not specific with respect to aromatic nature. You could use aliphatic as well. But Perkin is a characteristic of aromatic aldehyde. To this, I'm using aliphatic anhydride. We know what is an anhydride, isn't it? For example, I'm having CH3COOH, 2 moles of it. So I'll be forming this compound, isn't it? Ethanoic anhydride, acetic anhydride. So we are taking aliphatic anhydride here and salt of its corresponding salt, acid itself. That means I'm having this, its salt will be sodium acetate. In the presence of an acid, I heat it up. The reaction is very similar to your aldol condensation reaction. The only difference is that in aldol, I would have treated this with an aldehyde again, isn't it? Or a ketone. Here I'm using an anhydride here, which would get split up to form acid here. Other than the same thing is happening here. So we'll understand it with the mechanism that it follows. I'm having this acetic anhydride here. How did we generate it? I used 2 moles of acetic acid. Upon heating, the acetic anhydride is formed. CH3, COOH is there. Again CH3, COOH is there. Remove water molecule and then combine them. That's what we have written here. Okay. So to this, when I use a base, what will a base do? It will remove the acidic H plus. Look at this carbonyl group. To this carbonyl, the CH3 is attached. It is an electron withdrawing group. So definitely that carbon which is attached to carbonyl is feeling acidic. What is acidity? Release of H plus. So it releases H plus conveniently here. So that I have generated a carbanion. The next step you know very well. This carbanion would attack the electropositive carbon and the double bond would have got shifted. So that I have CH, O minus, CH2, COO, CO, CH3. The next step. I am giving H plus in the presence of water. So here, ma'am, I have O minus. This would have become CH, OH, CH2, COO, CO, CH3. Correct?
Yes, ma'am.
Now you could see that. Look at this unit here. CO, O, CO, CH3R is there. This is nothing but called as acetoacetic ester. What is a ester, ma'am? If it was OCOO or if it was there, I call it as an ester. But you can see again a COO group is there. So it is called as acetoacetic ester. When I hydrolyze it, the bond leaves so that the H plus gets attached here. But I end up with this an acid here. So this whole fragment goes away and I have an acid here. So this carboxylic acid is attached to this alpha, this is beta. So this is alpha beta unsaturated acid. The very common name for this acid is called as cinnamic acid. The
Ma'am,
acid,
if we heat the alpha comma beta unsaturated acid, then it will easily decarboxylate, right?
yes,
Then why is it not? We already heated this reaction, right?
no dears, further I am not heating it.
Oh, okay, okay, sorry. We got the we did the heat to get this.
Yes.
Yes, ma'am, got it.
So the reaction is called as Perkin condensation reaction. So how do I identify this Perkin? You would be provided definitely benzaldehyde in the presence of aliphatic anhydride. The moment you see this combination, just go and heat it. Create an alpha beta unsaturated acid.
What other aliphatic anhydrides? Can you give an example?
Perkin is especially done only for aromatic aldehyde, not for aliphatic aldehyde.
No, no, ma'am. The
Mm,
aliphatic anhydride, like the one in the
mm,
present.
mm.
Are there any other, what other examples, ma'am?
You can take anything. Here I am taking about acetic anhydride. Could be propanoic anhydride. Could be succinic anhydride.
Ah,
Anything.
yes, ma'am.
Okay. The questioner is asking you which will be reactive for Perkin condensation reaction. Which will be more reactive?
Uh, O2N, right? Like B.
D. That's the right one here. Because what you're going to attack is a carbanion. That means you're attacking a nucleophile. Nucleophile has to attack this carbonyl group of this aldehyde. The carbonyl should feel very electrophilic. NO2 is an electron withdrawing group. So it will increase the electrophilic nature of this carbonyl. But here I am having OMe, which is plus M group. I am having Me, which is hyperconjugation effect will provide it. Therefore, B will be more reactive for Perkin condensation reaction.